Hi, hello everyone. Welcome to my YouTube channel. Today we'll be designing a distributed job scheduler. This question has been asked in system design rounds for many product-based companies, including Amazon and PhonePe. So yeah, let's get started. What is a distributed job scheduler? It is a system where we will be giving some jobs which is to be executed at particular period of time. It can be repeated at some frequency, and it can be executed only once. As soon as when an interviewer gives you this question, what we are gonna ask him is what are the functional and non-functional requirements. We'll write down and clarify if it is okay for this round. So, in general, these functional and non-functional requirements will be good enough to start with. These functional requirements. First functional requirement is user can create a job on demand. Second one is user can provide task frequency. It can be repetitive as well, and we have to execute one job to 100K jobs per second. It can vary according to traffic. Now comes to the non-functional requirement. Our system which we are designing should be highly scalable. If the scale increases, it should not go down. It should behave as expected. Second is it should be highly available. There should be no downtime of system if any wrong inputs are given, or any scale is increased at any particular period of time. Also, we have to make sure that one job is executed only once. By this, what I mean is, like if a job is scheduled to execute at 10 a.m., it should not execute twice at 10 a.m. It may repeat at per the frequency which is provided in the input of that job. That is okay. So let's start with the design of this job scheduler. So what we are gonna do is we will be creating two APIs. First is a create job API. It is a post API where we'll be receiving inputs of what type of job it is, and what will be the frequency, and when it is expected to be executed. Similarly, we'll be having one get API. In post API, in the response, we'll be getting one unique job ID for every job, and that job ID can be used to get job details in the get API. So job ID will let us know like what is the current status of the job, how many times it is executed, and so on, depending upon the requirement. So comes to the design part. The basic design what we can come up with is like a user is hitting a job server to create jobs, and we are saving it in a DB. We'll discuss later on what type of DB we should use and why. And there is a cron which is running every second, because we can have this constraint like every job can be executed minimalistically at seconds level. Not We are not going in milliseconds level. So yeah, that will be one constraint. So this cron server will be running at every second, and picking a job at a time and executing it. It can pick multiple jobs also at a time and execute that job parallelly. So this can be done, but this design has many flaws. This job server single point of failure. If this job server goes down, the whole system will go down. New jobs cannot be added. Cron is also very single cron server, so if this cron goes down, jobs will not be executed from DB. And also it cannot scale at what requirement we have, like 100K task per second. So it cannot execute these many jobs in one go. So now what we'll do is we'll scale our system. Our system when we scaled looks like this. So there are multiple job servers which are gonna save jobs in a DB. we'll be having cron server which will hit our DB, and this cron server is just used to fetch which job is to be executed and put that job in a queue. That's it. So this queue we can use any asynchronous queues like RabbitMQ or Kafka, anything, and we can have now multiple instance of a consumer, which will be listening to this queue and picking jobs from there and executing them parallelly. So now our cron server responsibility is only to pick jobs from DB at which is to be executed and push it in a queue. Apart from this cron, as we can see, we have also added one recover cron. So what is this recover cron for? So we'll see like what we're gonna do with this recover cron. Now comes to the DB part. What DB are we gonna use? So since we have one requirement like every job need to be executed only once. So what we can use is basic SQL DB, since we'll be having a definite structure of our database. Plus we can use asset property of a SQL DB here. It will be really helpful for us. So now comes to the database part. We can have two tables. One is job and one is job schedule. Let me correct it. It is job. Yeah. So in job table, we will be having one ID, which will be the job ID. It will be the primary key of this table, and other columns we can have based on a requirement of what type of job it is, frequency things, when it will be started, when it will be executed, at what date it should be executed, like for a month, for 2 months, or every till the end of the time, like anything we can have here. Our main table is the job schedule table. This table will be used in cron server to pick data from here. So we'll be having one ID which will be job schedule ID, plus we'll be also having job ID here, which will be the foreign key of this table. There will be one column is execute at column. This will tell that this job is to be executed at which time. Now we also have one status column. It will be in enum, so it can have multiple states like it is created, it is in progress, it is in error state, or it is completed. What is this job's current status? So we can have like this. Plus if there's any error, we can save error reasons to display. Also how many number of attempts we have made to execute this job, and when was this job execution started. So yeah, so what we are gonna do is, like, there can be multiple cases. First comes to the happy flow. So what we can do is, we can, this job server will pick all the jobs which has to be executed at that particular period of time from executed at, and it will pick every job whose status is in created or in error, and if it is in error, then its attempt should be less than number of attempts allowed. Like let's suppose there are only 5 attempts. So this will only pick job schedule whose number of attempts should be less than 5. If 5 attempts are done and it is in error state, we'll not pick that job. So what we can do is, we can have a lock in this, like no other uh, uh, query can update this status of that all jobs which has to be picked, and we can update it in state of in progress. Now and also started at what started at only time at in which this job is getting into state of in progress. So this is the happy flow. So when these job IDs will be pushed in this queue, and the respective consumer will pick it, it will execute this job. And what else this consumer will do is, it will mark it as an error or success completed. based on the state, and if it is an error it will also increment the attempt count, and if it is completed then no need of that. Okay, so it will be marked as completed. So this will be the happy flow of our job scheduler, but there can be chances of failures. For example, let's suppose one consumer has picked a job, but that consumer goes down, or anything happens to that job. That job is in now is in progress state, and our cron server will never pick at that job because we have condition it should be in created or error state. So that job will never be picked. So what else we can do is, we are having this cron server, we can run it. So this cron server, what it will do is, like, it will pick jobs in this job schedule table and see that what all jobs are there which have status in progress, and its started time is greater than any threshold time. Let's suppose like 5 minutes or 1 minute based on the requirement. That threshold time has elapsed. Then what we can do is, we can mark this status as an error status and increase its attempt. And error region we can save like it is marked from recover cron, this job could not be executed. We can, so that we can know like why this was in error state. So next time when this cron server will run, it will check that what all jobs are in error state less than that particular time, executed at time. So that job will be picked again. Also, one thing, when this consumer is executing a job, what it else will be doing is, it will be having the job ID, job schedule ID. So what it will do is, it will pick job, read this table and see if that job has to be executed furthermore in future. So it will again create one entry in this table so that it can be executed later on also. So every time when a job is executed, we'll check like, if it is a repetitive job, we'll again create one entry here. So like this it can work, and it will now cover all the cases which are there. Now this design is pretty good. It can handle the load which we are expecting. It is also scalable. We can increase servers and number of consumers based on our requirement. Plus, it is also available all the time. We can have master slave architecture for database for high availability of DB. Uh, Plus, we can all we are having multiple instance of consumer and job servers, so that will be okay. So our functional, non-functional requirements are done. Apart from this, there can be other functional requirements also, like what about if we want to execute some job at priority. So we can have one extra column here which will tell us the priority of that job, and when we are picking these jobs, we'll sort by that priority. uh, and if there are some more priority items, what else we can do is, we can create one priority server, priority cron servers, or we can use of this cron server, we can have one priority queue. Priority queue, I mean one other queue which will be executing only priority jobs, and the consumer server for that queue will be different. Okay, so that can be also done. But let's suppose there are more chances of increasing load. What else we can do to scale this system? Although this design will be very good, if you give in an interview, it will be okay. But what about if we want to make it more scalable for higher traffic? What else we can do? So what else we can do is, we can do something like this. Okay, so what else we have done is, we have sharded our database. So our SQL DB can also be sharded since we are having only two tables, and we can shard it on job ID. So we can do some sharding job IDs, and we can also use one load balancer to pick which shard to listen. For this load balancer for picking the DB, we can use consistent hashing. I will be explaining what consistent hashing is in some other video maybe. I'll be adding that video soon of consistent hashing. So let's suppose this consistent hashing is a thing which help us to hash our hash key which is our job ID and tell us which DB that data is having. Okay, so similarly, we'll be creating cron servers and recover cron servers for every database. So, like, let's suppose there are n databases and shards of DBs. So we'll be having n cron servers and n recover crons also. So this cron server will only be picking jobs from this particular shard. Okay, and who is responsible for maintaining, like, every shard has its cron server and recovered cron. So we'll be having one cron db mapping service. We'll be creating this service, or also we can take help of zookeeper, which is from Apache. So it will help us to do this managing mappings. How this mapping service works. So this mapping service have idea of how many shards are there, because it can listen to load balancer APIs. So load balancer also have some set of APIs which it uses to do load balancing and saving instances and everything. So load balancer is also a service basically. So this cron mapping service can check how many instances are there of how many shards are there of this database, and based on that chart, it will have that many cron servers, and it all will also do some type of pinging that cron server it is okay or not. We are having some cron server or not. If not, we'll create one. So this will be doing all that thing, and again that cron server will be pushing message into queue. Will be consumed by some consumers, and consumers will again listen to the CDB and add data back into our job schedule table. So this design is pretty much more scalable, and it can handle much more traffic, because there can be cases like in every seconds maybe 10,000 or 1 lakh uh, jobs has to be executed, or more than a lakh, maybe more than 1 lakh, 10 lakhs. So cron server are this one cron server will pick that job and push into this queue. It will be okay, but this it will also take some time. So so now we have distributed the responsibilities of cron servers, and so that every cron server will have to pick only less number of jobs and push into that queue. And this queue can be scaled, like if we are using Kafka, it can be scaled easily. I'll be also creating one video of how Kafka internally works, how why Kafka is so much scalable and works on so much high traffic. So I'll be covering that too. Yeah, so that's pretty much about a load balancer. If you are giving this answer in any interview, interviewer will be happy and you will be selected for sure. So yeah, thank you so much for watching this video, and all the best for your interviews.